So here's AOR's AR-Alpha receiver, and we're running some more tests on it here. This time we're on the airband, and we're having a look at how the receiver gets completely blocked by aircraft signals from nearby aircraft. Okay, as you can see, the receiver is tuned to 120.575 MHz, which is a ATIS signal from an airport which is about 20 miles away. Now if you watch the signal meter, you notice how the signal jumps up and down quite a lot. This is actually an S9 signal here, but for a good percentage of the time the receiver is blocked, and it takes between 2 and 4 S points off the signal as other signals block the receiver. So let's switch this over to waterfall mode, and we can have a look at some of these stronger signals that are nearby. Okay, so now the alpha is in waterfall mode, and we can see this red signal here as a strong signal, and at the same time the band spectrum scope was going quite berserk, basically because these strong signals are completely swamping the receiver. Now this is supposed to be a commercial grade receiver, and it's an absolute disgrace how poorly this receiver performs. Again, you can see just a few strong signals. The red lines on the band scope is enough to overload the whole receiver. Again, there's the band scope going berserk. This time there were about 4 strong signals came up in the airband at the same time. We're looking at a 10 MHz window of spectrum across the display here. And again, there you go, 2 strong signals, or quite a few strong signals appearing in the 10 meg band, enough to absolutely block the receiver and completely wipe out the scope. Let's reduce the gain on the scope a bit so we can see these stronger signals a bit more. So we'll turn the scope down to -10 dB. So you can see on the scope here, the signals that are causing these problems are not massively strong really. There's one there about -50 dBm. It's enough to block the signal though, the S meter down at S7, up to S9 where it should be now, back down to S7, up to S9, down to S7. As the signals come and go, the receiver is completely blocked. As a strong signal appeared there, took the S meter down to S5, blocking the signal we're trying to listen to. Absolutely appalling for a commercial grade receiver. If you'd bought this receiver to use in an air traffic control system, it would be an absolute joke. The location here is nowhere near any airport, about 20 miles from an airport, so the signals you're seeing are just overhead aircraft, probably at a good few thousand feet as well. There's nothing low flying here. Okay, let's change the frequency now. I'm going to go to 128.6 MHz, which is London Volmet. And let's stick the scope gain back up again.
and 320 degrees. Cover test. Temperature 2.8. QNH 1024.
Again, there was a strong signal appeared there. It caused a heterodyne on the wanted signal, and again interfering with the spectrum display and causing quite a annoying heterodyne to appear on top of the wanted signal we're trying to listen to.
Birmingham at 1920. Wind 320 degrees 9 knots.
Again, if you watch the S meter, you can see it drop to S5 at the moment.
1024. Bournemouth at
Again, the receiver is being blocked. There, it's jumped up, it's gone back down again. Receiver being blocked by signals that aren't particularly strong.
QNH 1024. Bristol at 1920. Wind 260 degrees 14 knots. Visibility 10 kilometers or more. Cloud view 4,700 feet. Temperature 16. Dew point 11. QNH 1025. Cardiff at 1920. Wind 270 degrees 12 knots. Visibility 10 kilometers or more. Cloud view 4,000 feet. Temperature 16. Dew point 12. QNH 1025. Jersey at 1920. Wind 300 degrees 10 knots. Visibility 10 kilometers or more. Cloud view 1,800 feet. Temperature 16. Dew point 14. QNH 1026. Message.
There's an example there of some more blocking. There were about 3 or 4 signals that appeared relatively strong within the 10 meg window, enough to completely block the receiver. Again, the signals aren't massively strong. This is a commercial grade receiver should easily be able to accept signals of this level. If this receiver was used commercially as it's supposed to be in any kind of commercial system, it would just fall over. Remember, we're only using this at home in the amateur radio shack here, not on a massive antenna system. We're on a log periodic antenna, and it's a disgraceful design, and AOR really need to get this receiver fixed. All these reports that we're showing here have all been reported to AOR. They've had one go at changing the hardware on this receiver and 2 or 3 goes at the firmware, and as you can see, it's pretty appalling.
This is London from Birmingham at 19.
So that's how you can expect the AR-Alpha to perform on airband. A pretty disappointing performance for a so-called commercial grade receiver that costs $10,000 or 7,500 British pounds. So come back again when we'll show you some more of the faults this receiver has.